Record. Hello everyone, this is Heading Tian. In this video, we will learn chapter 11.6, event involving a note and or odds. So maybe this video it's a little bit longer than before. Okay, first one, find the probability that an event will not occur. We learned before that the event will occur, and now what's the probability of an event will not occur? Here, the complement of the event E. If we know the probability of E, I can P of E, the probability of an event E, we can determine the probability that the event will not occur, denoted by P of not E. For example, the event E is I will eat cereal this morning, and the probability of the event E, P of E, equals 0.8. I have 0.8 probability to eat the cereal. How about the complement? So P not E equals 1 minus 0.8. That's 0.2. That means by the percentage, I have 80% probability to eat the cereal, and I have a 20% probability of not eating the cereal. Okay, let's move on. The probability that an event E will not occur is equal to 1 minus the probability that it will occur. So P of not E equals 1 minus P of E. Then P of E equals 1 minus P of not E. Using set notation, if E prime is the complement of E, then the P of E prime equals 1 minus P of E, and P of E equals 1 minus P of E prime. Let's see some examples. So you see example 1, we learned about the 52 card deck. Sorry. So the card deck is very important. If you are dealt one card from standard 52 card deck, find the probability that you are not dealt a queen. It's very hard to find that you are not dealt a queen because so many cards, they are not a queen. But if you let the event E to be, you are dealt a queen. So what is the probability of you are dealt E? Oh, queen. I'm sorry, a queen. Right now we know this one are the queens. So there are 4 queens. There are 4 queens divided by the sample space, which is 52, is 1/13. This is the probability that you are dealt a queen. So not dealt a queen, that is P of not E. So P of not E, or P of E prime equals 1 minus 1/13, which is 12/13. Okay, let's move on to next example. Next part. 2, find the probability of one event or a second event occurring. This is the OR probability with mutually exclusive event. Mutually exclusive event, that's the events A and B are mutually exclusive if it is impossible for them to occur simultaneously. What's the meaning of that? What's the mutually exclusive? Just like two events cannot happen at the same time. You run forward and you run backward. So you run backward and forward. These two events cannot happen at the same time. Another example of the mutually exclusive, you toss a coin. It could be a tail, it could be a head, but you cannot flip a tail. Flip a coin. You can't have the tail and head occurrence at the same time. So these two events are mutually exclusive. Let's move on to see the highlighted part. OR probability with mutually exclusive event have some formula. If A and B are mutually exclusive events, then P of A or B equals P of A plus P of B. Using the set notation, we learned this OR before. That means union or. P of A or B equals P of A plus P of B. Okay, let's move on to the example. Example 2. If one card is randomly selected from a deck of cards, what is the probability of selecting a king or a queen? So king and queen, they are mutually exclusive. So, so from the picture, okay, here you see king and queen, they have nothing overlapped. So they are mutually exclusive. That means I can use the formula. That is the P of this formula. P of A or B equals P of A plus P of B. Okay, let's solve this. The solution is shown here. P of king or queen equals P of king plus P of queen equals, because there are 4 cards, king card over 52. This is the probability you dealt a king plus the probability that you dealt a queen, which is, we have 4 queen and we select them from the sample space is 52. So just to find a simplify this, you got 8 over 52 and that's a 2 over 13. Let's move on. Example 3, you are dealt 1 card from 52 card deck. Find the probability that you are not dealt a card with a number from 3 to 6. You know we have a lot of cards, 52 cards. You dealt number, you were not dealt a card with number from 3 to 6. You think you should say 3 to 6 is easy to find, but other number is not that easy. So let's the event to be the E to be you were dealt a card from 3 to 6. So if I want to find the probability of not dealt in a card with number from 3 to 6, I just use 1 minus the probability of P of E. Okay, let's find the P of E. P of E equals, so how many 3 you can find? How many 3 you can find? You have, you have 4 3s over 52. And how about 4? Because 3 to 6. So you have 4 4s in 52. 52 plus 4 5 in 52 plus 4 6 in 52. Okay, that's 16 over 52. And to simplify this, we have 4 over 13. How about 1 minus the P of E? That's equals 1 minus 4 minus divided by 13, which is 9 over 13. Okay, let's move on to the next part. Or probabilities with events that are not mutually exclusive. We learned this 2 events are mutually exclusive. How about not mutually exclusive? If A and B are not mutually exclusive events, then the probability that A or B will occur is determined by adding their individual probabilities and then subtracting the probability that A and B occur simultaneously. So in the words, we should say P of A or B equals P of A plus P of B minus P of A and B. Using the set notation, P of A or B equals P of A plus P of B minus P of A and B. Let's see some examples here. Example 4, suppose that these cards are shuffled and you randomly select one card from the deck. What is the probability of selecting a diamond or a picture card? So you see or, so you need to add the probability of selecting a diamond and the probability of a picture card. So if right now, we just don't consider about the mutual exclusive or not mutual exclusive. So pretend they are mutually exclusive. So P of diamond, I just use D to represent selecting a diamond, plus, because this is or, plus a picture card. So what's the probability of that? A diamond, we have 13 diamond over 52. And how about picture? We have 12 picture cards. That is 25 cards over 52. But when we go back to see the 52 decks here, you will find these are all diamonds and the picture cards here. And if we count, we can't find 25 cards. We only find the 22 cards. Why? Because the overlap part here, these 3, they are both diamond and pictured. So we need to subtract these 3 cards. Okay, so we must subtract the overlap. So P of diamond. I'm not sure what happened. Okay, I read it here. So P of diamonds plus P of the picture cards minus P of diamond and picture card, which is, we learned that these two is 25 over 52 minus the overlap. I have 3 cards, 52, that is 22 over 52. Simplify that, 11 over 26. Okay, let's move on to next question. Example 5. In a group of 25 baboons, 18 enjoy grooming their neighbors. 18 enjoy grooming their neighbors. 16 enjoy screeching wildly, while 10 enjoy doing both. When you see doing both, that means it's not mutually exclusive. They have overlap. They do the both things. Continue to read the question. If one baboon is selected at random, find the probability that it enjoys grooming its neighbors or screeching wildly. Solution, let's see. So if they have the or, you need to have the probability of grooming and plus the probability of screeching and minus the baboon who like both, which is 18 over 25. 8 plus 16 over 25 minus 10 over 25. We get 24 over 25. Okay, let's move on to next question. You are dealt 1 card from 52 card deck. Find the probability that you are dealt 4 or a red card. So the probability of dealing a 4, OUR, plus probability of red card and minus 4 and red. That is how many 4s? We have 4 4s over 52. 52 plus red. How many reds? Diamonds and hearts. They are all red. We have 26 over 52 reds minus the diamonds and the hearts also have the 4. So we have 2 red 4. So they are both diamond and red. So it's 2 over 52. What's the result of this? Let's see. 28 over 52. Okay. We have 7 over 13 because divided by 4. 7 and 13, all divided by 4. Okay. Let's move on to next question. Example 7 illustrates a spinner. It is equally probable that the pointer will land on any one of the 8 regions, number 1 through 8. If the pointer lands on the borderline, spin again. So there's no chance, we don't count the chance that land on the border. what are these? Okay. So if the pointer, find the probability that the pointer will stop on an even number. So even number, or on a number greater than 5. Find the P of even number. I use E to present that. And then P of the number greater than, greater than 5. What's the probability of this? So even number, we have 1, 2, 3, 4. 4 out of 8. And the number greater than 5. This one, this one, this one. We have 3 numbers. 3 over 8. And how about the overlap? They are both even number and greater than 5, which is 6 and 8. So both is even and it's also greater than 5, which is 2 over 8, because we have 6 and 8. So if we want to find the probability that a pointer will stop on even number, even doesn't work. Why? Even or the number greater than 5. Oh, my pen doesn't work well. I use my finger to write on it. Okay, that is 4 over 8 plus 3 over 8 minus 2 over 8. What is that? 7 minus 2 is 5 over 8. So this is our answer. Okay, let's move on to next page. Example 8. The table shows the marital status of the US population in 2015. Numbers in the table are expressed in millions. Let's see. The question A, the person is divorced or male. So find the probability of the person is divorced, and also we should find the probability of the person is a male, and then minus the intersection. That means both divorced and a male. So A is the probability of divorced plus probability of male and minus probability of the divorced and male. That equals divorced. We find here is divorced, and find the total, because it doesn't mention about a female or male. It just say is divorced. So use the total. 26. What's the sample space? Sample space is here, the total of all the people in this table. In the population shows us, which is 254 plus male, who is a male. So use the total of the male, which is 1, 2, 3 over the sample space 254 minus the overlap. This person is divorced male. Divorced male is here. 11 over 254, and then find the result of this as this 69 over 127. It's about 0.54. Okay, number B. The person is married or divorced. So married, we find it here, or divorced. So do they have overlap? Can a person be married and divorced? No. So these two events are mutually exclusive. So we just have P, married, we use capitalized M, plus P, divorced, equals 133 over 254 plus 26 over 254 equals 159 over 254. It's about 0.63. Okay, let's move on. Next question, the mathematics department of college has 7 male. So I prefer to list all the information here. So male professor, I will use MP. MP, we have 7 and 5 female professor. FP, we have 5. 7 male teaching assistants. So teaching assistants, TA, is 7, and 9 female teaching assistants. So, oh no, here is the male teaching assistant. Male teaching assistant. This is female teaching assistants. We have 9. Okay, 7 male professor, 5 female professor, 7 male teaching assistants, and 9 female teaching assistants. And totally, how many people are shown here? It's 28. There are 28 people here. So the question is asking, find the probability that selected person is teaching assistant or female. That means we need to find the P of teaching assistants, TA, and plus a person is a female, and minus person is a female teaching assistant. So P of TA, what is the P of TA? In these two part, these are all TA. That means TA, the probability TA is 7 plus 9 over 28, the sample space. And the female, so this one and this one, they are all female. So 5 plus 9 over 28 minus female teaching assistants. We only have 1. We have 9. So 9 over 28. So 7 plus 6 is 13 plus 14 plus 9 over 28. Oh, sorry, it's minus 9. It's minus 9. What is the result of this? That's 3 over 4. Yeah, just to simplify this answer. Okay, let's move on. The third part is understand and use odds. If we know the probability of an event E, we can also speak of the odds in favor or odds against. So odds in favor, odds against. The following definition link together the concept of odds and probabilities. If the P of E is the probability of an event E occurring. Then first one, the odds in favor of E are found by taking the probability that E will occur and dividing by the probability that E will not occur. For example, the odds in favor of I eat the cereal this morning. So the P of E, if I eat a cereal this morning, the probability is 0.8. So the P of not E should be 1 minus 0.8 is 0.2. The odds in favor of E equals 0.8 over 0.2. So 0.8 over 0.2 is 4 over 1, or you can say 4 to 1. 4 to 1. And the second definition, the odds against E are found by taking the probability that E will not occur and dividing by the probability that E will occur. That means odds against E, that means the numerator part should be P of not E. The denominator is P of E. That's the reciprocal. Just flip it, make it upside down of the odds in favor of E. So remember, when they ask you in the question, odds in favor of E, the top is P of E. Odds against E equals P of not E on the top, on the numerator. Okay, let's move on to the example. You roll a single 6-sided dice. Find the odds in favor of rolling a 2. Remember, the sample space we know is 1, 2, 3, 4, 5, 6. The event E is 2. So odds in favor of rolling a 2 equals the event of E rolling a 2 divided by not rolling a 2, that equals 1 minus P of E. That means P of E equals 1 over 6 because the number of E is 1. The number of sample space is 6. So P of E equals 1 over 6. So the denominator is 1 minus 1 over 6 equals 1 over 6 divided by 5 over 6 equals 1 over 6 times, flip it if I want to make it on the top, equals 6 over 5 equals 1 over 5. Okay. No, I have the result here. Okay, let's move on to the second one, B. Find the odds against rolling a 2. So just to find the reciprocal of a favor of rolling a 2, we have 1 over 5, or you can say 1, 2, 5. So odds against E equals 5 over 1, or 5 to 1. Next example 11. The winner of raffle will receive a new sports utility vehicle. If 500 raffle tickets were sold and you purchased 10 tickets, what are the odds against you winning a car? So the P of E. Now, the probability of you winning the car equals, because you bought 10 tickets and the sample space is 500. Thus, So the odds in favor of the E equals P of E, which is 10 over 500 over 1 minus 10 over 500. So we need to simplify this. The top part should be 1 over 50, and the bottom part is 49. 1 over 50 times 50 over 49 equals 1 over 49. You can also make it in ratio is 1 to 49. Okay, let's move on. Read the question carefully. That is not looking for odds in favor. It's looking for odds against your winning a car. This is the odds in favor of your winning a car and the odds against of E. Odds against E equals the reciprocal of this, which is 49 to 1. So read the question. When you put your answer in my math lab, maybe it doesn't show you you make it right because you didn't read the question carefully. This is odds against of the E. So that's the reciprocal of odds in favor of E. Okay, let's move on to next one. This is the last question of this lesson. Example 12, the shaded regions in the circle graphs shows the percentage of children in United States whose parents are college graduates in one parent and two parents household. Use the information shown to solve the parts A and B. This picture you will see this pie graph. You will see the shaded region, the red part. That's the percentage of the children whose parents are college graduate, and this is in one parent's household, and another part is in two parents' households. In the question part, the question asks you what are the odds in favor of a child in two parents' household having a parent who is a college graduate. It's only asking you two parents. So the graph here, you don't need to care about this. I'm just working on the second graph. So sometimes the graph confuses you, but you need to figure out which one is useful, which one is useless. Okay, let's see. We need to find the odds in favor of child in two parents household having a parent who is a college graduate. So the college graduate, I just use E to represent who is the parents are the college graduate. The percentage of this event equals 23. 23 because it's shown us in the picture because the red part here is 23%. So how about not E is equal 1 minus P of E equals 77%. So the odds in favor of E equals P of E, which is 23%, divided by 77%, which is 23 to 77. 7. And next part is asking you, don't need to see this part. What are the odds against a child in two parents? So this is asking you the odds against a child in two parents household, having a parent who is a college student. So that means we just need to care about the second picture. There's nothing to do with the first picture, first pie chart. So it's asking you the odds against the child, two parents. That's the reciprocal of odds in favor of child in two parents households having a parents who is a college graduate. That means the reciprocal of this, which is 77 divided by 23, or you say 77 to 23. Okay, this is the video about chapter 11.6. If you have any question, let me know. Okay, have a good day.